All right, let's get started. So last time we talked about cross-site scripting, and so today we're talking about the defenses against cross-site scripting. So first, though, some admin. So this Thursday is the guest lecture on browser fingerprinting by Pete Snyder from Brave Browser, and feel free to invite friends or anyone you think might be interested to come. And this Friday, the assignment 1 is due, so hopefully that's going well. I noticed there's a lot of questions going through on Piazza, so it seems like people are making progress. There's going to be office hours, of course, this week, so come in if you're having problems or if you're stuck in any way. Cool, so just to review, last time we talked about cross-site scripting, and the basic idea was we have user data that we're combining with some kind of code, and when we do that, if the user input is specially crafted, then it can produce a resulting page which runs the attacker's code. And what we want to try and do is actually escape the user input so that it's treated by the browser just as user input and not as actual code, right? And remember, the context here is that the attacker is trying to get this code to run in a browser of some user of our website. And so if the attacker succeeds, then this code is running in one of our users' browsers, and they're presumably logged in or they're viewing some kind of sensitive information. And so it's not our website server that's getting attacked, it's the user's browser who's visiting our website that's getting attacked. OK, so we also talked about there was two kinds of cross-site scripting, reflected and stored. So remember, reflected is a bit easier, sorry, not easier, but rather a bit less powerful in the sense that we're only sort of able to manipulate like a URL. And if the attacker manipulates the URL in some way, they might be able to get the server to reflect back some piece of data that was in that URL in a way that it's treated as code by the end user's browser. And in stored XSS, the attack code is somehow added into the database, and then it gets returned by the server on potentially any number of different responses. So it's a little bit more powerful there. Any questions about that? Cool, so it's all review, yeah, so that's good. So one thing I was thinking about is a way of thinking about what's actually going on here in both of these types of attacks. This might be a useful way to think about cross-site scripting. So there's like different sort of context shifts that are going on when an attacker is producing an attack like this. So sometimes we're injecting downward by creating a new context where one wasn't expected. And then other times we're sort of doing the reverse. We're sort of like ending a context and sort of going back up. So what do I mean by like this down and up? Well, remember the DOM is, it's a tree. So it's sort of this tree structure of all of the HTML tags on our page. So some tags have other tags in them, which have other tags in them. So it's this tree structure. And so we can sort of go down by adding a new context into a node that wasn't expecting that to happen, or sort of go up, end a context, and go up into like a different context. And so if you look at the code here, so what's going on in this case, where our user data was a script, this would be is this down or up in this case? Down, right? OK, yeah, exactly, because we sort of added a new node into the DOM. And then in this example here, we were putting user data into an attribute, and the attack was sort of to oh, I guess I copied the wrong thing here. This is actually properly escaped. So this isn't the actual attack in this situation. But say that we were able to sort of escape out of this. This would be injecting up, right? So ending the context of being in an attribute and sort of being now out into sort of being able to create our own attributes, right? Cool. So yeah. So the idea behind these defenses is that well, just to review, the core problem is this untrusted user data being combined with code. So actually, I think the name cross-site scripting is a little bit misleading. We should probably be calling it HTML injection. And that sort of parallels nicely with what we're going to talk about later, which is SQL injection and other kinds of server-side injections. But basically, the idea is we're sort of inserting new unexpected HTML. And so our solution is to escape or to sanitize this user input before combining it with the code. And we talked about the different characters we have to worry about last time. And so where can all this untrusted user data come from? We have HTTP requests from the user, so query parameters, form fields, headers, cookies, all kinds of data that comes from the user. We have to worry about this. But also data from a database, because we don't know how the data got into the database. So this data could be added by any number of different people on your team, and you don't know whether that data is sort of in a clean format that you can just sort of dump into your page. And so you have to be sort of conservative and do not trust it and escape it sort of on the way out, right? And there's also third-party services. Sometimes you get data from a third-party service. Who knows if it's safe? Who knows if it's returning you data that you can just blindly add to your page? Furthermore, even if it is returning data that you can blindly add to your page, what if tomorrow the service is hacked and now it's returning data that you can't trust? So better to design your code in a conservative way where when you get data back from anybody, you ensure that it's safe to add to your page before you just add it. Does that make sense? Yeah.
Just really quick, would you mind turning off the light?
Oh yeah, I forgot. Just feel free to always remind me if I forget. Cool. All right. So when do we want to escape? So I sort of mentioned this before, but we have sort of two choices. You could escape on the way into the database, or you could sort of escape on the way out at the time you're sort of rendering your page. And this is more for the stored XSS. But what are some of the trade-offs here? What do we think we would prefer to do in this, for this trade-off? Yeah.
I think I'd prefer to escape on the way in because you only need to do it once. But if you're escaping on the way out, you have to do it as many times as a user requests that API.
That's true, yeah. So if you do it on the way out, you're going to be repeatedly doing it. The downside of doing it on the way in, though, is you don't necessarily know the context in which that content is going to appear. And remember last time there was all these different contexts we could put the content. We could put it inside of an HTML tag or in an attribute or in a script string. And because we don't really know where our data is going to appear, it's actually safest to just assume that it hasn't been escaped and to just do that at the time of rendering, because that's where we actually know I'm about to take this string and put it inside of this context or inside of that context, and we can make the correct decision at that time. So, yeah, I'm not saying you can't do it correctly that way. You totally could if you know for sure that you're going to be using it in particular contexts. But in general, it's preferred to do it at the time you're producing the HTML string. Does that make sense? Cool. So yeah, always on the way out at render time. And I think I sort of said this. You don't really know in advance what context that is going to appear in, and every context has different escape characters we have to worry about. The other thing too is you might have somebody on your team who's not you, because you're going to write perfect code, but some other person is going to show up, and they're not going to know that we have a policy here at this company of always escaping our data at the time we add it to the database. So somebody might write some script that just dumps more entries into the database that are not following your rules, and then now you're in trouble. Cool. So how do we actually do this escaping? So I mentioned we sort of went over some of the things where we talked about which characters we would need to be worried about. But actually, most web frameworks come with built-in HTML escaping functionality, and so you should just use that. And there's this cool law named after Linus Torvalds from the Linux project, just called Linus's law. And it's basically the idea is, given enough eyeballs, all bugs are shallow. And so this just means that if you're using code that's depended upon by a ton of people, and it's in your framework, and it's open source, we hope that somebody will find problems in that code if problems exist. Versus if you write your own escaping functions and then you're the only one using them, now you're not really sure if it's correct or not until you're attacked. So this doesn't always turn out to be true in practice. Like there was a famous bug called Heartbleed, which was actually in plain sight for many, many years, and people didn't discover it for a really long time. So this doesn't always prove to be true. And in fact, sometimes it's the opposite, because people think, well, oh, it's open source. I'm sure that thousands of people have looked at this and have audited it, so I don't need to bother. And so oftentimes people might actually worry less about open source code than if it was code that they themselves wrote or something like that. But anyway, I'm going off on a tangent. So so basically the idea is to just know to know how your particular framework provides HTML escaping functionality and to just use that. And also, you need to know it's not just enough to blindly use it. Again, the reason why we went over all this stuff is because it's not actually not enough to just say, oh, my framework takes care of it, because there's all these different contexts we talked about. So you need to know what exactly it's escaping your untrusted data for. So for example, if you're using HTML escaping, you can't just take that output and put it into a string in a script tag, unless it's actually escaping all those characters. And similarly, you can't put it into a comment unless it's doing that. So anyway, just make sure you know what it's doing. So I wanted to go through a little example here. So there's a templating language called EJS, which stands for Embedded JavaScript. And it has this interesting, like simple syntax here, where we just use HTML tags, and then anywhere where we have some piece of user data that we want to add into our page, we can use here. Let me see if I can use this remote. We can use. There we go. Yeah, cool. So yeah, we can use this right here, this percent equals syntax. And what this is going to do is it's going to take this JavaScript value, evaluate it, and whatever it returns, it's going to escape it and then put it into the page there. And so if we do that, we're fine. And it also supports some other things like this this syntax here, where you can sort of write arbitrary JavaScript, make your template do different things. And then you invoke the template by saying, that's the template I want to render, and this is my data that I want to sort of insert in. Cool, so that seems reasonable. React has something similar. So React is, you take some HTML string like we have here, like in this case, hi. And if we want to put it into the page, then we use this sort of interpolation using an angle bracket there to put it inside of this div. The thing is, though, if you try to do this, it's actually going to escape it. So React is going to say, we think that this is untrusted. This could be some random crap from the user. And so we actually want to, we don't want to treat that as true HTML. We're going to escape it. And then you might think, well, aha, I know how React works. In React, I'm supposed to I can put whatever JavaScript property I want in here as an attribute, and then it's going to set that as, it's going to assign inner HTML to this string. And normally that is what works. But in order to protect you from yourself, React actually makes this not work. So what's interesting is both of these sort of obvious ways of like trying to put a user string into a div are not going to let you do what you think it's going to do. It's going to, in this case, it's going to escape it, and in this case, I believe it's an error. So how do we actually take some string, and if we really know that this is safe, in this case, like here, we know this is actually safe. Let's say we wanted to add this to the page. How would we do it? Well, in React, they have this attribute called dangerously set inner HTML. And it's not only enough to just make the value be that. You actually have to make the value be an object with an underscore, so 2 underscores, so it's extra scary. HTML property, and then you make the value be the actual string. And so when it sees this, it's going to say, OK, all right, you must know what you're doing. We're going to assume this string here is safe, and we're not going to run our escaping function on it. We're just going to stick it in the page. It better be safe. In other words, you, the programmer, better have made it safe already by the time you call this. So what's nice about this is this looks ugly. That's actually a good thing, because if you see this in a code base, you should want to refactor it. You should want to be like, ugh, why are you if you see your teammates and you're code reviewing this code, you should want to ask them why did they do this instead of something less ugly. And that's nice. That's actually good. That's a feature here. Does that make sense? Any questions? Yeah, so I like this design in React. They also have this is kind of unrelated, but they have this hilarious other property called secret DOM, do not use or you'll be fired. There's actually been people opened up like issues saying like, why is this property named this? Can we name it something shorter, like just do not use? And they're like, no, we're keeping it this because we really don't want anyone to use this. We want people to be afraid. And only people who really know what they're doing will maybe feel free to use this. So this is also a funny thing I found as another idea. You can make a function, and if you really want users to not use it for some reason, you can actually add like an additional argument where they have to pass in a string that's like some terms that they're agreeing to. If they don't pass that exact string in, then the function will throw an exception. And so it's very ugly to use, but it's nice because you sort of know that they must have agreed to this, and they must see that they must see this string at the time that they're calling the function. Anyway, these are kind of tangents, but the point here is just that the opt-out from the safe behavior should be sort of difficult, and I think React does a good job with it. But I want to show you sort of a bad example where they didn't do a good job of it, and that would be this EJS templating language, which I do use, and it's actually quite nice. It's just it doesn't make it it makes it a little bit too easy to do the wrong thing. So let's see how that might happen. So I'm going to make an Express server here, and I'm just going to make it listen on port 4000, and we'll just add a really simple route for the home page. And all we're going to do is just send back some HTML. And let's actually define what this HTML is going to be. So the way that this works is, I believe EJS has a render function that takes in a template and then some variables. And so let's say that we're going to have a name, and we're just going to try and put my name into the page. Can everyone see this? Is this visible? OK, I think it is. It's big enough, right? OK. Yeah, so now let's make the template. And so this is that template sort of syntax that we saw before, where we're just going to let's make this page just be an H1 that says hi, and then the name of the person. So we use this % equals name equals, or no, I think it's % that. I think that's the syntax. OK, so that's our HTML template. And then we're saying render that, but substitute in for us anywhere where name is used, and that's going to escape it. So this should be safe. Let's go ahead and actually see if that works. So here we go. So I'll load up localhost, and it says for us. OK, cool. And if I change this to, let's change this so that it actually. Actually, before I move on, let me just make sure we all understand. Like it just put the name right there, right? OK, so now let's do something slightly fancier. Let's make it pull the query parameter out so that the name can be specified sort of by the user who's visiting the page. And if we do that, and then we take that name and put that in here, does everybody know this syntax right here? What I'm doing here is this is just saying the key is name, and I want the value to be the name variable in this local context that we're in, which is just going to be that. If I want it here, I'll be less fancy. Then we won't have to be confused. OK, so that's what's going on. And so now I can be pretty sure that this is safe, I think. So if I refresh this, oh, right, I need to default it to something. If there's no query parameter set, we'll default it to a named person. OK, so now if I go in here to the URL and I say name equals for us, it works. And if I change that to be name equals script alert hi, we're going to get what we want. Cool. So the only thing that's really worrying about this is if I were to make a mistake in this template and accidentally type a dash instead of an equals, then we have total disaster. We're completely owned. So now this script is actually apparently not running. I don't know. Why is it not running? Oh, haha. OK. That's actually something we're going to get to in a second. So let me hold off. I'll just switch to a slightly different browser, and then we'll see. OK, so it works. So yeah, so what's going on here is, right, that script is, does everyone see that? It's just in the page, and it didn't escape it. So anyway, the lesson here is just that, like, I think this templated language makes this like way too easy of a mistake to make. Like if one of your colleagues submits this in a code review and you just happen to miss this like single character, then you've just introduced a massive security hole into your website. So it's a bad design. Yeah. OK. So let's continue. So yeah, and then they have all these different confusing prefixes. They all do different things. And then these are the two where this is like totally fine. We're all dandy. This is like disaster. So they're way too simple or too similar. So let's continue and talk about what we can do if we just assume that this is going to happen, XSS is going to happen, our site is going to be attacked in this way. We saw like how prevalent this is. So maybe the right strategy is not just to try to be very careful and to avoid it, but also to just assume it's going to happen, and then think about ways we can be safe even when it does happen. And so that's what we're going to talk about now. So remember, the core problem here is the attacker's code is running in the same page as in the same page as the page. So this is the page that we wrote all of our code in, and it has user data in it, and it has user cookies and all kinds of private information. So how can we make sure that when the attacker's code is in this page and it's running amok and doing whatever it wants, that we're somehow still OK? It seems like a tall order, almost impossible. But there is a way. And the concept here is called, it's this key idea of this class and of all computer security, which is the idea of defense in depth. So this term means we want to provide redundant security so that even if one measure fails, it will be saved by another one. And so the attacker now has to find multiple vulnerabilities and in order to produce a successful attack. We sort of have multiple layers of defense. So can anyone think of any examples of defense in depth in computer systems that you might have used? Mm-hmm.
So I know for some cases when you're like downloading files on the newest version of Safari, like it'll say like, do you want to allow like downloading files from this domain? And then depending on the file, you'll have to like right click and click open and then click open again just to run it.
Yeah. That's particularly annoying sometimes, but yeah. So I think the idea there is like that Safari has a built-in way of detecting when you're visiting a malicious site that they're hoping to sort of throw up there and warn you about, like, don't proceed. Are you sure you want to proceed? And say that you proceed anyway. Even then, like, you end up downloading some malicious file. You still have to sort of be a relatively advanced user and know how to right-click open instead of just double-click, which I guess. If you're such a basic user that you don't know how to right-click open, then maybe this is actually protecting you. So I guess that's the idea there. Anyone else have any other ideas? Mm-hmm?
Two-factor authentication.
Yeah, that's a great example. So even though you've hopefully set a really strong password, and you know that no one can guess your password, you're still using a second factor. You're still saying that even if an attacker were to know my password, they would also have to physically have my phone or my second factor device. So that's a great example. And then even in that situation with the password plus two-factor, there's even a third thing, which is that oftentimes you'll still get you'll get an email from the service saying we noticed that you logged in from a new location. So even if you lose your someone gets your password and they happen to get your second factor, there'll hopefully be some kind of an audit trail that you'll be able to see and know that I got hacked and I can sort of respond in some way. And so this is just an example of defense in depth. I have another one. Oh, that's interesting. I've not heard of someone. I mean, no. I think I've not heard of that. Yeah, but that was because DES was insecure, and they were like, well, just do it 3 times in a row, and then it'll be better. Yeah. No, I don't know. Yeah. I feel like that in that situation too. It's actually if you encrypt something twice and then you lose either key, now you're in trouble. So it's actually doubled the risk of you losing access to your data. But maybe if you gave those keys to different people or something, it might work. But anyway, I think we're sort of stretching the metaphor at this point. So I'll move on. But this is defense in depth. Anyone have any questions about it? OK, cool. So let's talk about a way to do defense in depth. Specifically, we want to defend the user's cookies. So we know that the attacker is running their code in our user's browser. And they're trying to steal that user's cookies. If they succeed, they're going to be able to take the cookies and log in as that user from their own attacker computer. OK, so we talked about a way to defend against this with HTTP-only cookies. And remember, the way this worked was that even if the attacker is running JavaScript in the page, they can't access this value. So when they call document.cookie, it will be as if this cookie was not in the browser. So hopefully that's familiar. and specifically like this attack that I've been showing over and over again, where you just exfiltrate a cookie using an image, this would not work because document.cookie would not return this key value pair. Does that make sense? Cool. So and then just quick review. So why would we do this? So I mean, or how would this value actually end up being used if it's HTTP only? Why would we even bother? Like how do we actually get to use this cookie now? It's included as a header, exactly. So whenever we make API, like if we make an HTTP request to some endpoint on our server, like /API/something, that cookie will be added automatically, and so our server will be able to see it. Exactly. Cool. OK, so this is a really fun thing that I didn't have time to get to last time. This is really cool. So there's this feature that. Oh yeah. OK. Before I go, yeah, you have a question?
Sorry, the previous
Sure. Yeah.
slide.
Yeah.
So doesn't that mean if I can somehow like attack this page and make a request from this page, I can still use the cookie?
That's totally right. Yep,
Okay.
You're right. So this is not like this by itself. If you do this and you think, like I'm safe against XSS now, like attackers run your code in my site, you're still going to have trouble. Like so the idea here is just we sort of mitigated one potential thing that they could do.
But ultimately, if they can run scripts on your website, no problem.
Yeah, that's right. Yeah, that's right. If they can run scripts on your site, then they could do all kinds of things. They could change the page. They could delete your account. They could do whatever they want to the user. Yeah. But we're going to combine this with a bunch of other things, and then together they sort of collectively make a really nice set of layers of defenses. Yeah. But that's a really good point. You're right. This does not fully protect you. OK, so here's a really cool idea. So Chrome was like, OK, so XSS is a huge problem. Everybody keeps making XSS vulnerabilities in their websites, and almost everyone's vulnerable. So what if we could just help everybody out? Like just make it go away. So they had this awesome idea, which was, how about this? When we load a page and we're parsing the HTML for that page, if we notice that there's something in the URL that matches something in the page, then maybe that was a reflected XSS, right? Maybe the server was tricked and would actually it reflected out something that it got in as input out into the output. And so what if we see that, we should maybe just block it, just like don't let that script run. And now we've protected the website, even though the website's insecure. Like the browser is smart enough to effectively refuse to run that attacker code, right? Seems like a good idea, right? I mean, can anyone think of what might be bad about this? Like I can't. I mean, a first look at it seems like it's a good idea. Yeah.
You can make, I guess you can include stuff in the query that it then parses to, it'll think that it's like bad code, but instead it's like friendly code, and it just kills it from the server code, and you just kill some friendly code.
Exactly, yeah. So that's what we're going to talk about, yeah. So that's right. Yeah, so yeah, let's go into it. So, well, first of all, before we go into that, I just want to mention, it also had a bunch of false negatives, too, so it was possible to get past the filter quite easily. One thing you could do is you could change the query slightly and encode it in different ways, and then if it got echoed out, Chrome wouldn't be smart enough to tell that input was the same as that output. But the much bigger problem is the false positive problem that you mentioned. So in particular, there's no way to know whether a given script block which appears in both the request and the response was actually truly reflected, or if somebody just added it into the request to make it look like it was a reflected XSS attack. So let's make that concrete. So say we have a page, and the page has a script alert hi in it, and say that this is supposed to be there. Like this is code that the site author included. So they're happy to have this code run. Now, if the user visits this page, then the XSS auditor is not going to do anything. It's going to think that everything's fine. It's going to run the script, no problem. But if the user visits the page and they attach this query string here, query equals that script that appears in the page, and the auditor is going to think that was reflected into the page, right? And so it's going to conclude it's an attack, and then therefore it's going to sort of neuter the script and make it not run. OK, hopefully we're starting to get some ideas, things we could do with this. So I'm going to show a demo of this. So let's go to our bank site that we've been building. And let's just add a little script here into the page. OK, so I don't want to type this, so I'm just going to steal it from something I already wrote. OK, so what we're doing here is I'm just including that frame busting code that I mentioned before, and we have better ways to defend against being framed. Remember, we have an HTTP header that we should use instead, but just to make this this demo, we're going to use this method of sort of detecting that that this page is in a frame. And so the idea here is the bank doesn't want anyone to put it in a frame, and it's going to use this JavaScript to ensure that if it detects that it's in a frame, it's going to set the whole browser's location to the bank site, and so that frame will sort of bust out and take over the whole page. And so that way the bank has sort of prevented itself from being framed. Hopefully that's familiar. So we're going to add that script to both pages if the user's logged in and if they're not logged in. OK, great. Now I'm going to go to a file that's going to represent our attacker. And our attacker is going to try and include a frame now to this bank. And the bank, I think, is called Target on port 4000. And so this should fail, because the attacker is framing the bank, and the bank just wrote that script. So let's see if that's true. So if I go to my browser and I load Target 4000. Wait, oh, sorry, I'm running two servers. I need to switch to running different server. OK, there we go. So here's our bank. Perfect. And let me just confirm that the script appears in there now. Excellent. So now we'll go to our attackers page, and OK, so notice what just happened. I visited the attackers page, and the whole browser redirected to the bank. So that means that the frame busting worked. Let me just confirm that that's true. If I open up the inspector here, we look at the requests. We can see if I visit attacker.com. Let me just clear this really quick and do that one more time. OK, there we go. So what happened was we loaded the attacker's HTML here, which was I guess I can't see it very easily, but the point is that we loaded up the attacker's page, and then we were sort of forcefully redirected to the bank site because that script ran. OK, so now let's see if there's a way that we can cause that script on the bank to not execute. So let's just let's test this out by directly playing with the URL here on the bank site. So I'm going to let's view the source, and let's just copy this script, because this is the script we want to prevent from running. So if I copy it, and I just put it into a query parameter here, query equals that script. Now, it looks like nothing's different, but if I view source, this is in red now. So this is Chrome saying, it looks like you have an XSS in your site, and we're going to protect you by making this script not run. OK, so now if the attacker just copies that URL and puts that into the frame here, and then now we load up the attacker page. I think the only issue is it's cached, so I need to visit that while my inspector's open. But there we go. So now the bank frame is there, and the attacker's allowed to frame it. So we've sort of neutered that script that was a little bit inconvenient for us as an attacker. It seems like a problem. We can sort of snipe out particular scripts that bother us from sites that we're trying to attack. Not good. Any questions about this? Yeah.
What's the disadvantage of just doing that stuff before it gets to the server and it comes back with JavaScript in the DOM? Can you just look at the query and be like, this is stupid?
Oh, could the server just look at the query and say that looks like
your browser? Right when you query the server,
oh, could the browser prevent you from making a request that looks malicious?
Yeah, just query question mark equals script whatever.
Oh yeah.
The browser can just be pop up you're stupid.
So that would work. I think that would break some legitimate sites. So some sites are actually coded in a way where they pass HTML from one page to the other through the query string, and it's a bad idea, but I guess you could do that safely, right? If you're actually filtering the tags, but you expect that to work, and your suggestion would break that.
If sites do that, then doesn't this solution break that use case anyways? Because then it deletes the script from.
That's true. Actually, you're right. And how is that use case supported then? Huh. I think that this is fine if it's not dynamic content like scripts and stuff. But yeah, that is true. Yeah, I'm not sure. But yeah, it's let's move on. So, but any other questions? Okay, so anyway, they realized this was a bad idea. So after like I think 6 years of this being deployed, and a ton of bypasses being found, the sort of policy that they came up with was, well, we don't think bypasses are that bad. This still protects people some of the time. It catches some attacks. Let's keep it there. So they didn't consider being able to bypass it as significant. However, when people started pointing out, well, you could sort of snipe out scripts that you don't like from sites you're trying to attack, then they took that more seriously, and they switched the default behavior to be that I think instead of it just removing a script from the page, it would entirely block the page from loading. But anyway, now the current policy is that they're just deleting all this. They just considered it's a bad idea. Concluded it's a bad idea. So actually, if I switch over here to Chrome Canary, which is the latest version of Chrome that is sort of in beta right now, and if I visit that page, what do we get here? Oh gosh, wow, that is hilarious. So two things just happened here that I have to point out. This is actually, I did not expect this, but it's very interesting. So let me first copy the target URL here that has the attack in it, and I'm just going to go over here now to the beta Chrome, and I'm just going to show you that that it doesn't try to block it out. So if I give me 1 second. Why is it being escaped? I thought that it was supposed to be an attack. Oh, right. I'm okay. Here, two things are going on here. Yeah, so the point is that the script is in the page, and you notice that it's not read. It's not read even when I put the script into the URL. So yeah. So the point is that they're no longer filtering this out. That the auditor has been removed from Canary. But what we saw happen was that redirect block thing is actually another security feature that just actually kind of got me in trouble here, because what I wanted to happen was I wanted the frame busting code to run and the bank site to take over the page. But Chrome has a feature that prevents iframes now from redirecting you, which just interfered with what we were trying to do, which is really annoying. So the reason they do this is because there's a phenomenon on the web now where ads will actually, in addition to just like sort of showing you an ad, they'll try to just like take you elsewhere. And so like sketchy ad networks will just navigate you elsewhere, and this prevents that. And I think the reason why they decided this is an acceptable trade-off, even though it just broke my defense here, is because we have a better way to actually do this defense, which is an HTTP header that says, I don't want to be framed. And that's what we should have done. So if we had done that, then we would still be fine here. But wow, all these different interacting things. I mean, this is an example of why security is hard. OK, let's move on. But yeah, that's the XSS auditor. It lets us snipe code out of the page, and in about 7 days, all your Chromes are going to auto-update to remove it. You can do this now. You can snipe. Yeah, you can attack sites by sniping code out like this for 7 more days. Yeah, I'm actually glad that I was able to show you before my Chrome auto-updated and made it really hard for me to demo it. Yeah. So, and then just one other point is just you can do this for more than just inline scripts, but even if there's like, let's say a bunch of security code in some particular file, you can also snipe that out. If this code is assuming that this is loaded, you would just include basically this piece here, and then that script just doesn't load. Yeah. So it's a problem. Okay. And then one other thing I want to show that this is actually okay. Before I show it, let me just give the context. So. There's a whole nother attack here as well, as in addition to disabling scripts you don't like. So if you, so what is going on here? We have this way of basically if we put something in the URL that appears in the page, then Chrome will sort of interfere with that. Will block the page from loading, right? So if we use this, we can actually detect when things are like particular strings are in the page, right? So if I want to say, steal some variable that's a session token or something that's in your page, I can sort of include a prefix that tries to match that. And if it matches, the whole page will be blocked. And if I can detect that, then now I just discovered that string is in your page, right? Are people following this? I see some confused faces. Let me try to explain it one more time. So what did we show? We showed that basically what's going on here is if this string is in the page, then this page it's loaded differently. And in particular, it's actually blocked. The entire page is blocked from loading. Actually, the site can opt into fully blocking it, or I think the default is that it snipes it out, like I said before. But let's say the whole page gets blocked, right? So now I can sort of by setting this string very carefully, I can test for the presence of particular strings in the page. Yeah.
So is it because the iframe, because the browser blocks this address because it's an iframe?
It's
blocks anything that has to do with this?
No, it's because the auditor is saying we think a reflected XSS is happening. And so if the site has said via a header that it prefers when XSS is detected that the whole page is blocked, then my attack site now can sort of put a string in here and then watch to see whether this iframe fires an on-error event. And if there's an on-error event, then I know this string must be in the page. And I'm not supposed to be able to tell that because of the same origin policy. But I'm able to sort of trick the browser into revealing that fact to me. And so if I try a bunch of things, I can actually learn a lot of stuff. Like in a simple example, I could sort of maybe include a username and to see if that appears in the page, and then I know that that's the user who's on my site. But more maliciously, you could actually iterate through like a token that appears in the page and try to steal it out of the page. And I actually have a video of that here, which is a wild video. So this is a page that includes a secret token in the page, and this is an outer page which is iterating through adding things to the query, basically. And every time it finds a match for a prefix, then Chrome blocks it from loading, and then the page learns that is in the page. And it's just like in the movies where you see that it's breaking the password one character at a time. It's just like that. Yeah. So this page is going to learn the full token there. Yeah. Anyway, so this is a bad idea. This XSS auditor is quite a bad idea. So let's talk about a different way of actually protecting our sites, especially since the XSS auditor is going away. So we mentioned last time, or two times ago, that we have certain ways of tightening up the same origin policy to sort of prevent other sites from posting forms to us or loading images or scripts or styles from our site. And that was a way of sort of defending our site. This thing called CSP is sort of the inverse of that. So this is a way where we can actually prevent our site from making requests to other sites. Now you might think, well, why do we want to do that? That seems weird. Well, remember, we're trying to defend against an attacker's code running in our page, and we want to limit what they can do. So if we assume the attacker has JavaScript running on our site in one of our users' browsers, it would be great if we could say, you know what? That code is not allowed to talk to any server except for like my server. And now they can't sort of exfiltrate any data, right? I've sort of sandboxed them in. So this is an added layer of security against cross-site scripting. So obviously we don't want attacker code to be running in our sites, but if it is, wouldn't it be great if we could just say, like, sorry, you can't talk to all these different servers. You can only talk to this particular whitelist of like maybe 3 servers that I trust. And now the attacker is very limited. They can't actually steal any information except they can talk to those 3 servers. And if you control those 3 servers or whatever, then they can't do anything, right? That's the idea. So we need a way to actually specify this policy in a way that the JavaScript can't interfere with it, obviously, because we just said the attacker has code running in the page. So what are we going to do to set this? We're going to use an HTTP header. So with an HTTP header, this is coming directly from the server when it provides the HTML, and it's saying, this is a policy that I want you to enforce for all the code running in this page. And so now, even if the attacker's code is in that page, it's too late for the attacker to do anything to change this policy, because this policy was included in the HTTP header that the server sent back, right? Does that make sense? So yeah, basically we add this header, and then the CSP will go ahead and block any requests that violate the policy. So maybe it would help if we look at a few examples, I think. So here's a really simple policy. If you add this header to your server's responses, then you're basically saying, I want the page to only be able to talk to the same origin. So now if an attacker happens to stick a script tag in there, they can't talk to any other servers. There's very limited, in terms of what they can do. Although your point, I forgot, what was your name?
Yachin.
Sorry?
Yachin.
Yachin. So your point was that that they could still make requests to the same site, and that's still true in this context as well. Their code could do things on behalf of the user, but they can't steal any data now in any way because we've sort of prevented requests from going out to any other sites. Does this make sense? This is the simplest policy, so hopefully this makes sense. If not, ask questions now because we're going to add a lot of complexity in a second. Okay. So say now we want to, let's test our understanding really quick. So would this be allowed? So if this HTML appeared in a page where that was the header that was sent back on that page, would this be allowed? Yeah, it would be, right? Because this is just loading a JavaScript file from the same site, right? OK, so relative URLs will load this file from the same origin, so we're fine. Would this be allowed? Obviously not. It's a different site, right? Different origin. OK, what about this? Unclear, right? Well, remember, we're trying to defend against cross-site scripting here. So it seems like if we let the attacker just write code in line, that we're not really that safe. I mean, most of the attacks we've been showing have been us just calling alert on the cookie, or writing code directly in line. And so it's actually not very much of a defense to tell the attacker, you can't load scripts from your attack server, but you can write whatever code you want. Right? That's not a very good defense. So actually, this policy will by default prevent all inline scripts from running. And so you need to be sure when you do this that you're not sort of breaking your own website. You need to make sure basically all your code now appears in hello.js or something like that, an external file. But this is really powerful because now we're basically saying the attacker can't stick code on our page and they can't load code from their site. So all that they can do is hopefully they could hope to have some way of maybe affecting this file, but that's a whole other kind of an attack. That's not cross-site scripting, and so this actually sort of seems like it defeats cross-site scripting, right? Yeah.
So this is not really a question, more of a confirmation, but it seems like this is another reason that having different files on your server is much better than putting everything in one. It's not just a stylistic thing, but it's actually for security.
Yeah, I mean, in this situation, you're right. Yeah, because we're sticking a bunch of user data into the page, and now we know that if it happens to be a script, it's not going to run. Yeah, that's totally right. Yeah. So yeah, that's great. And then one other example here. So what about if there's code inside of an attribute, like an event handler like that, like on mouse over? Should that be allowed? For the same reason as this was denied, I think we also want to deny this, right? Because if the attacker happens to get something in there, now they're running code again. So we want to block that as well. So yeah, that one line right there just sort of it seems like it completely saved us from cross-site scripting. That's great. So cool. So now what if we want to change the policy slightly, relax it a little bit? Say that we trust trusted.com, and we want to let them load. We want to load scripts from subdomains of trusted.com. Well, we can just add trusted.com there to the list of sites that we trust. So that's pretty simple. Let's go through an example now where, say we're a webmail provider, and we're trying to just load the scripts from our same origin and then maybe subdomains of our site. And then we also want to allow images to be loaded from anywhere because images can't really do very much. So let's say we're OK with images coming from any location. When we write a policy like this. So yeah, not too bad. So here's a question. Say that an attacker manages to get a script in this page. Although I guess they can't because of what we said about this line here would block the script from running, right? Yeah, I think this is actually a silly question. Let me skip it. OK. So what I want to mention now is deploying CSP. So say that you think that this header is a good idea and you want to add it to your site. One problem you'll have is that you might think like, OK, I know that I'm loading images from here and here and here, and I'm loading a couple scripts from here, and these domains. And if you miss one, though, and then you deploy a policy, you've actually just broken your site for all your users, because you've told the browser, don't let these resources be loaded. And so that's really bad. And so we have a way of deploying a CSP in report-only mode. So you put the policy here, and you just say, look, if there's a violation, it's fine. Let the code run. But please send a little request to a URL somewhere where I will be notified, and I can look at those reports, and I can see what exactly would have failed in production, and I can adjust the policy before before I actually deploy it for real, and I remove the report-only part. So this is a way to sort of test it out, and this is important if you're deploying it on an existing site that's really complicated. Cool. And then there's one other thing, which is so then when you actually do deploy it, maybe you still are a little bit paranoid that you might have made some mistakes. You can also include a report URL, which will get pinged anytime anything is blocked. And so you can watch those reports and see, like, OK, I guess I forgot that one edge case there, and you can update it. Other thing that's kind of cool about this is if an attacker is playing around with your site and trying to find attacks, every time the CSP blocks it, you'll get pinged, and you'll be able to see like attacks happening in real time against your site. Well, not real attacks, but an attacker playing around with parameters in your URLs. Cool. So there's a whole bunch of these directives. So I showed default source earlier, but there's like a whole bunch of different ones. I'm not going to go into all of them, but just point out a few. So we talked about images already too. We could sort of say we want to load images from these particular locations. Object is a really interesting one because it's all this sort of old Flash and Java applets and things that can be embedded in pages. If you're not using that stuff on your site, just block this entirely. And then scripts are probably the most important one to set a policy on, because this is really what we're trying to do here is prevent cross-site scripting. So you should be very careful about how you set the script source. Cool. And then there's a few other ones which these are interesting because if you look at the old list here, if you don't set a policy for any of these, then it inherits from default source. So you can just set a default source to be like my own, just same origin, and then you don't have to set any of this other stuff, which is kind of nice. And so you can sort of just change a few that you need to change separately from default source. But then these ones don't inherit from default source, so you actually have to set these separately if you care about them. And there's some interesting ones in here. So this one is kind of interesting. So there's this tag called base in HTML, and if you include it in a page, then all the relative URLs in the site become relative to whatever is specified in base. So if an attacker can put a base tag on your site, then they can say like base is attacker.com. Then any of your code that is sending a request to like /API whatever or any endpoint basically that is relatively specified will just have the attacker.com prepended to it, and the data will go there instead. So yeah, this is a tag that you probably want to have a policy about, and in particular you could just prevent it. There's not really a good reason to use it. But yeah, that's interesting. And then this one's also interesting. So frame ancestors lets you say I don't want to be framed, and I mentioned before there was already another tag for that. So this is a sort of duplicated way of doing it. This is the newer way of doing it. Oh, and then this one's also quite interesting, upgrade and secure requests. So this is useful if you have a site that is, again, an old site and you're trying to migrate it to be more secure. You want to have all of the requests that happen to point to HTTP URLs be magically upgraded to HTTPS. You can sort of apply that as a policy to the whole page, and the browser will do that for you. But yeah, these are pretty different from, in general, these seem pretty different than XSS, but they're part of content security policy. OK. Any questions? All right. OK, so let's talk about actually deploying it. So here's a script that appeared in one of my websites. And so when I was going to deploy CSP, I was like, OK, so I need to load something from Google Analytics, because I want to track how many visitors are coming to my site. So I said, OK, let's allow scripts from Google Analytics, and also from my own site, obviously. And for everything else, let's just default to only allowing it from my own site. So images, videos, everything else will just be only allowed from my own site. So this seems pretty safe, right? Like code can only run from Google Analytics or from my site. I like that, right? Seems good. So what's the problem? Well, we mentioned before that actually somebody tell me what the problem is. You should know this. I said it earlier. What's the problem? Inline code, yeah. That script tag up there is inline code. So this policy is going to deny that. It's going to say that could be attacker code. It's inline. You should put that in a separate file. Well, that's kind of annoying. In this case, I could put it in a separate file, no big deal. But sometimes you can't. Sometimes you have some kind of like ad code or something that you're putting on your site, and it has to be in a specific format. So yeah, unfortunately, this policy is going to block these inline scripts, which is going to prevent my Google Analytics from working. But there's this thing I can add called unsafe inline, and that basically says let inline scripts be OK, like don't block those. The problem with that is that's basically equivalent to having no content security policy at all, because now we're back to the situation where the attacker can put whatever they want in. But that would solve the problem. A better solution would be to move the code into another file, host it on our own site. But for now, let's just throw this in here because I don't want to change the HTML code. So that's a bad idea, but I'm going to put it in there anyway. OK. So there's still another problem. This CSP here is too restrictive. It's going to break our site. What's the problem? Seems fine. Yeah?
The Google Analytics script tries to get something from somewhere else.
Yeah, that's right. So when the Google Analytics script runs and the JavaScript executes, and now it wants to sort of save information about what the user did on our site. Like in particular, this thing right here, send page view, this is going to actually ping a URL using an image, like I showed the code I showed before, where you do new image.source equals whatever. And when it does that, it's going to basically be attempting to load an image, and our policy says images can only be loaded from our own origin. And so we just broke Google Analytics. So we actually have to, yeah, so this is the code they're running internally. They're making an image that points to Google Analytics / whatever collect equals some data that they're collecting, right? So we need to now say, OK, fine, you can load images from Google Analytics. OK. This works, but it seems like this is kind of fragile. Like we're sort of now making our policy sort of dependent upon what the code in here is going to do. And if Google decides to change what this script does or what domain it talks to, then we've broken it. So it's actually not a good. It's not ideal. So yeah, we could say, you know what? Let's just make the image be anywhere because images are pretty harmless. And so now I guess that's a little bit better. If they change the location that they're talking to, we'll still allow it. But we still have the same problem. Like in particular, there's a thing that they actually that scripts often do, which is this script might include another script to load some more functionality, and then that script could come from a different page. And now we've broken Google Analytics. So this is code that actually used to appear inside of this script. It would make a script, point it to ssl.googleanalytics.com, and then add that to the page, and that would get blocked. And so you'd have to add that as well. And so this is just, it's really hard to get right, basically, because it's based on this sort of runtime behavior. What is the script going to do? I better make sure I allowed that in advance, or else I just broke my site. And so for this reason, people have actually been very hesitant to deploy this, even though it's such a good defense against cross-site scripting. It's just so fragile, you might break your site, and people prefer to not have broken sites. And so it's just been a very hard thing to roll out. And so we need a way to basically ensure that our CSP never breaks our site, even when new scripts are added. And so here's an idea. What if we propagate trust from the initial script, which we trust, to any scripts that it includes at runtime, which we now want to implicitly trust? And we do that no matter where that script comes from. That seems like it would work, right? So we're basically saying we trust Google Analytics. They could put whatever code they want in there that might be malicious. We know they're not going to do that. We trust them. So why don't we just also trust them to load code from wherever they want? Because we already trust them. It doesn't seem too bad to just trust them to load code from any place they want, right? So that's the idea. Questions about this? Cool, yeah. OK, so there's this paper that some Google people wrote called CSP is Dead, Long Live CSP. And it talks about how they basically analyzed all these sites that have deployed this to protect themselves, and they discovered like extremely damning results. Like it's ridiculous. I have some quotes here. So 14 out of the 15 domains most commonly whitelisted for loading scripts contain unsafe endpoints, and as a consequence, 75% of distinct policies use script whitelists that allow attackers to bypass CSP. So this is just saying they trust domains where effectively an attacker can upload code. Like they can put whatever they want there. So you said, I trust that domain, but anyone can put stuff on that domain. And so what did you actually, well, you didn't accomplish anything by saying that by adding that policy. Another thing, so here, 94% of policies that attempt to limit script execution are ineffective, and 99% of hosts with CSP use policies that offer no benefit against cross-site scripting. That's like, why are we even trying here? Like, this is just so bad, right? Okay, so the good news, though, is in the end of the paper, they proposed a solution. And that solution has been deployed, and it actually works great. So there's the silver lining here. Okay, let's first talk about the things they mentioned in the paper that allow bypassing the CSP policies. So here's an example. I kind of mentioned this before with the JSON-P. Remember where this is an endpoint where it's going to return us some data, but we're asking that server, please wrap the data in a function named this. But in this case, if an attacker can put some code in here, and then they can make that return sort of anything they want. Now, it's really bad if we trust this server now, because we're saying we trust any code that comes from this server. But if an attacker can get this script in the page, they can make that server run whatever code they put in the parameters here. And so we got no defense from that. Does that make sense? So I guess I should have included an actual domain in the URL there. But what's going on here is we're saying we trust this site to only return us, we trust this site to return us like safe code, and we're going to allow that code to run. But it's possible for an attacker to create a URL that makes that site return whatever code the attacker wants. And so it's a really bad idea for us to trust a site that has such an endpoint on it. Mm-hmm?
So are you saying that the attacker basically hacked the other sites because they had a security loop that allowed attackers to somehow intercept whatever response that they were trying to give us?
So they're not directly like attacking the site. This site happens to have a URL that if you go to it, it will echo out whatever the attacker gives it. And if it can get it to echo out valid JavaScript, then now the attacker can basically it's effectively like they're putting whatever code they want on that site. But it's actually just echoed in this case, but it has the same effect. Yeah, okay. So let's show another example here. So this is an example using AngularJS. So it's typical in AngularJS to include the library and then to include template code. And then the JavaScript up here will actually look through the page and find code that matches template. And then it will run the JavaScript that's in the braces here. And so if you have Angular on your page and you think that your CSP is protecting you from arbitrary code execution, the thing is, so you as a site creator, you've said, I trust Angular. Like I know Angular is not malware, so I'm going to trust allowed.com to load Angular from there. The problem is that if an attacker can make divs in your page, which presumably they might be able to do because divs are not code, so you might let the attacker control some divs, and you let them put braces in the divs. Well, Angular is going to come along later and see these braces and think, I should execute that, right? And so now you've given the attacker, again, arbitrary JavaScript execution on your site. So to attack this, you would put some actual malicious code inside of the braces. So it's just things to think about, right? Like, even if you trust Angular, what is it doing? And how can the attacker control things that would affect its behavior? OK. And then here's another one. This is a really wild one. So say that you have an endpoint on your server which returns an error. It says error : and then in this case, this is supposed to be like a URL and then not found, like it's a 404 page. What we could do is we could try to visit /alert document cookie blah blah blah, and the page is going to say, the site's going to say, wait a minute, that's not a URL. So it'll say error. It'll say that's the URL you tried to visit is not found. And my question is this valid JavaScript? It actually is. So this syntax here is a way to name a line of code, and then you can use a goto to sort of jump to that line of code, basically. It's not literally goto, but it's effectively like a goto. And so we've named this part of our code error, and then this is the code we're going to run, and then we sort of commented out the rest of the page. And so again, if we trust this site, but it has this 404 page implementation, then we're in trouble. Because now attacker can basically put whatever code they want onto that site. Mm-hmm?
Does the script now look at like the return code of the, like does it read 404?
Oh, interesting, the 404, huh. I wonder, if you return a 404 from a script, and then, but it's valid JavaScript, would it execute? I actually don't know. I don't know. So maybe that would prevent this. This is definitely getting into sort of esoteric territory for sure, but you know, my guess is it would actually execute it. That would be my guess, but I don't know. Okay, and there's even more wild attacks. Like, say the attacker can control some data inside of a CSV file. This again might be possibly valid JavaScript. Like, if name is a variable and value is a variable, this will just echo name and value and then run this code. Really quite esoteric, but anyway, the point is that CSPs are hard to get right, and so there's this site called uselesscsp.com, which collects examples of people who failed to do CSP correctly. And if you go there, there's a whole bunch of big companies on there. Like I think the top result right now is Apple is on there, and Apple's CSP is completely ineffective. Yeah. And I think right now their SSL certificate is expired. So if you try to go there, they're also a failure in in some ways. So if you just ignore that, you can actually see the site. Security. Yeah. So anyway, so basically, the solution to this is what was proposed in the paper, and it's a really great solution, and this is what you should use, and it solves sort of all the problems that we've talked about. So it's called strict dynamic. And the basic idea is, instead of specifying in the policy for scripts that all the list of domains that you know might ever be contacted by code that you trust, you can just say, look, I'm just going to implicitly trust certain ones and then let those load anything they want, and just sort of cascade the trust onwards to anything that they may want to load. And so that's great. So now we're going to load some code from trusted.com in this example. But how do we know that we can trust this script? How do we know this script is not attacker-injected code? Well, the HTTP header here included a nonce. In this example, it was ABC123. So this is just going to be a random value that the server chooses. And then what it's saying here is it's telling the browser, look, any script that you see in the page must include nonce equals that value, ABC123. If it doesn't include that as an attribute, then it means that it was attacker-injected. And so, in both of these examples here, both of these scripts will be allowed to run. Even the inline one here is fine. And the reason is that we're saying we trust any script that has the nonce on it. And so that has a nonce on it, so it's allowed to run. OK. So, question? Yeah.
I don't know if you answered this later, but so you declare the nonce when you were setting the CSP?
Yes, this is in the HTTP header.
And you declare the nonce value?
You declare the nonce's value as ABC123 in this example, and then you have to, then all the HTML, all the scripts in the HTML have to have the same value. Yeah. Mm-hmm.
How difficult is it for an attacker to also see that nonce?
Yeah, so that's a great question. So, so it's really important that, OK, what was I doing here? Oh, right, yeah, OK, so here's an example where, the attacker tried to inject these last two scripts here. So they tried to add evil.js, and they tried to include some attack code. Now, these two scripts are not going to run. And then your question was, like, how come the attacker can't figure out what this nonce is, right? Who knows why? Like, who can think of why? It might be hard for the attacker to figure this out. Yeah? Yeah, that's, so can you expand on that?
Well, presumably, like the attacker would need to like read in like the nonce from this site, right? So, but attacker.com doesn't have the same origin.
Yeah.
So you can't read the nonce.
Exactly. So the idea is that that initially the server sent back a page, right? And that page includes this nonce sort of in the header and also in the page. Now, how can an attacker possibly see that value? They can't look at the headers of a page, of a response that came back from a server, and they also can't look at a nonce that's in an HTML page of another origin. They just can't. It's a different origin. Now, you might think, well, couldn't they run code that looks at the nonce? Like, couldn't they look at the nonce attribute in the page? But the thing is, then you're assuming then that they're already running code in the page. So if they're already running code in this page and they can look at the nonce value, then you've already lost because they're already running code in this page. So if they're not yet running code in the page, now they have to find some way to figure out what that nonce is. And what we're doing is we're making sure the server picks a different nonce every time it sends back a page. So this is a completely random and unpredictable value. And so because it's completely unpredictable, the attacker can't just know sort of a priori, like the nonce is going to be this, so when I include this in my URL for my attack, they can't know what the nonce is going to be. Yeah?
Does that mean HTML can't be cached anymore? Like your pages can't be cached?
Yeah, so HTML responses you definitely not want them to be cached if you're using CSP like this, yeah. But the good thing is usually HTML isn't cached anyway because you have like personalized information for the user, like when they're logged in, you show their name in the header and stuff like that, and so usually you don't cache that anyway. But it's just a kind of a crypto term for like a random value, random string basically.
How does it protect the web page?
So it's protecting the web page because the server is selecting it, and it's completely random. And then when the browser gets the HTML for the page, it's going to look at this header and say, OK, I'm being told by the server, don't trust any scripts that don't include that nonce as an attribute. And so if the attacker manages to say, let's say they do a stored XSS, they get this script right here, evil.js, this one, they get it into the database somehow. Well, when it gets echoed back out into the page here, it's completely inert. It's not going to be allowed to run because the browser was told not to run it unless it had a nonce attribute that was valid. Mm-hmm.
What counts as a page load?
Page load? Well, I guess a request to an HTML page from the top level, like the URL and the URL bar of the browser.
Okay, and I guess what would prevent someone in the stored XSS case from storing it with some nonce of like a matching length and just refreshing until the nonce? I guess it depends on how long it is.
Yeah, so that's a great, you understand this, you understand the problem perfectly. So you need to make sure the nonce is long enough that it would be impractical for them to iterate over all of them. Yeah, like in this example, ABC123, that's way too short. I should have made it longer. I should have included a ... or something. Yeah, that's way too short. Yeah. Cool. Great. So that makes sense. So there's one problem, though. Some browsers don't support this strict dynamic thing yet because it's really new. In particular, Safari doesn't support it. And so we have to decide what are we going to do when Safari users come to our site. So one thing you can do is you can so the way that content security policy works is that the browser will ignore things that it doesn't understand. So it will ignore strict dynamic, and it will ignore nonce. And so what we can do is we can just sort of have these other really unsafe properties in here, saying like load scripts from anywhere and let code run in line. And when Safari sees this, it's going to say, OK, I'm just basically applying no security policy here. And if you do that, then Safari will the code will work, and this won't break your site. And then when you run it in another browser like Chrome or Firefox, or Edge or whatever, then it will see this and it will say, OK, strict dynamic and nonce actually tell me that if those are present, I'm supposed to ignore any of these other ones. And so you can sort of, in a single policy, you can actually have fallbacks for browsers that are old, because this actually won't run at all in a modern browser. So this policy is actually great. It doesn't really protect the Safari users, but hopefully the fact that most of your users are protected is good enough, and that would hopefully discourage an attacker from bothering if they can only sort of target a smaller percentage of your users. But you could also include the full list of domains that should be used here as well if you want. I'm too lazy, so I just put star unsafe inline, and I just figure those users, sorry, sucks to be them. But yeah. Mm-hmm.
So for a single page, like is only one nonce use, say like a script requests like another script, for example, like does that script like also need to use
The nonce?
that we provided?
So that's a great question. So if you've included a script tag like this one here, trusted.com, and it includes a nonce, it can just dynamically create DOM elements that are scripts and add them to the page, and it doesn't have to even include a nonce. The fact that it is the code inside this script that is running will implicitly allow it to just do that. The browser won't like restrict that script in any way from adding other scripts. The trust cascades basically automatically.
Okay, so it can just like, okay, so.
It doesn't have to change its code at all. Like this code doesn't have to be aware that nonce is even a thing. Like it can just add scripts to the page.
Okay.
Yeah. Cool. Okay, so here's just an example of a reasonable starter CSP header you could use if you're building a site. Okay, a few other things. So there's this other thing called feature policy, which is kind of cool, that lets you say, I want to completely disable certain browser functionality in my site. And this is yet another way we can sort of limit the damage an attacker can do. So you can say, like, the geolocation API, like, I don't want, if an attacker gets code running in my page, I don't want them to be able to get the user's current location or something like that. And there's a whole list of other ones that they're planning to add, which are not currently supported, but which eventually will let us sort of ban a bunch of browser features that we know that we're not using. And so why would we want to let an attacker use that as well? Yeah, the web can do a lot of things. In particular, there's a thing on Hacker News the other day, I think yesterday, about this thing. People were using the ambient light sensor to fingerprint users. Yeah, because sites could literally look at the light conditions in your room without a prompt at all. So they could just tell, are you in a light room or a dark room? And like, apparently, like that's yet another way to sort of get another data point on a user. I'm sure that Pete is going to talk all about this on Thursday.
Wait, if you block your camera, would that still be able to work?
I guess it's using the light sensor on your phone. So
Oh, on the phone.
yeah, it's probably next to the camera. Yeah. Cool. Okay. So, oh man, we have like 3 minutes. I wanted to mention one other kind of XSS called DOM-based XSS. So the idea behind this is that the DOM can be modified by a script that's running in the browser, and we might actually trust this script. But it's possible that an attacker could trick that script into adding some DOM nodes to the page that we don't want it to add. So unlike reflected or stored XSS, the attacker is not actually changing the HTML that the server returns. But what they're doing instead is they're somehow at runtime getting the page to do something unsafe like this. So why is this unsafe? This is fetching like my bio. Like say this is a social network. It's fetching like Feroz's bio, and then that's going to go into a string. And if that contains HTML, what this is doing is it's adding it to the page, and it's saying treat the HTML in this string as like actual tags. Add them to the page. So this is very dangerous. And so the correct thing to do in this situation is to just use text content instead of inner HTML, and then it will treat it as text and do the escaping for you. But you can see how this would be another XSS vector. And so this is actually the one that's more common these days because all the kinds of client-heavy frameworks that we're using, like React, are all just making this kind of attack more common. But there's this new browser spec, which is not shipping in any browser, but which is going to be coming in the next year or so, which also completely solves DOM-based XSS. So I wanted to make sure you all knew about it, or at least heard the name of it. So CSP protects us from reflected and stored XSS. And then for this DOM-based XSS, the idea is if we have this kind of code like this, we would like to be able to say, basically, we don't want to be able to say inner HTML equals some HTML string. We want to sort of make that be an error. And so the way we do that is we use content security policy to say we're using the trusted types API, and we would like all of our inner HTML equals code to fail if it's passed a string, and only to succeed if it's passed something which is a type trusted HTML object. And so what that means is now how do we produce one of these trusted HTML objects? Well, they're going to come from a very particular sort of factory for those. And so we're saying here in the header is we want to use this factory that we call template. And so we make a template factory, and then we give it a create HTML function, and then it takes the user input and it just escapes it. But while this may look like it's returning a string here, it's actually it is returning a string, but then this factory will actually return a trusted HTML object. And so now if I get back Feroz's bio, and I get it back as a string here, I have to now create a trusted HTML object using this factory, and then now if I set it, it will be allowed. And so what's cool about this is literally now in this example here, the only way to ever add any HTML code to the page is to go through this factory. So all other places where you might set HTML strings into the DOM, all throughout your whole code base, they all must flow through this one function, or else they're going to be blocked. And so now when we want to audit our code, it's very, very easy to audit it. We just look at this function and we make sure that this function is rock solid. If this function is safe, then we know there's no other way that anybody could have added any DOM-based XSS to our site. So that's a very interesting approach that I'm a fan of. Yeah, so final thoughts. So yeah, XSS vulnerabilities are pervasive in real-world sites. Be very vigilant. And never trust any data from the client. Always sanitize it. And be aware of the context that you're using the data in. And make sure you escape it appropriately depending on the context. And then use CSP correctly with strict dynamic. And soon you can use trusted types. And if you use those two things together, you'll basically prevent all kinds of all the kinds of XSS that exist pretty much. And so that's great. If you do it right, you can have a site that's safe against the most pervasive web attack that exists. And you can never be too paranoid. So just constant vigilance. That's the right mentality. Thanks. See y'all later. See you Thursday for the guest lecture.